Thanks so much for inviting me out here. This is my first time giving the scientist talks and kind of excited by it. I know the title was slightly different, so this isn't going to be a complete bait and switch. I will be talking about the net illumination work, but I thought I would try to put it in a broader set of context of why we do what we do. And so with that, the title of tonight's talk is International Conservation Efforts and Developing Bycatch Reduction Technologies and Tackling Indigenous Take. This story isn't going to always be the most pleasant story. I think some of my other colleagues who came before me the 2 weeks talked a bit more about the life history or the physiology of the animal. I'll be talking about how we interact oftentimes with these animals and what some of the drivers behind their declines are going to be and what we're doing to kind of resolve some of those issues. Before I get into the talk, just wanted to let you guys know I am from NOAA, National Marine Fisheries. I'm based at the Pacific Islands Fisheries Science Center, now on Ford Island. I'm not with the turtle program. I'm actually with the Fisheries Research and Monitoring Program, which means the work that I do takes a very different point of view. The point of view that we're often thinking about when we think of turtles is like, oh, here's the turtles, the natural history of turtles, the different types of turtles, etc. The point of view that I've been involved with is, what do the fishermen do with turtles? When we fish, when we go and take resources out of the ocean, are we also taking sea turtles and other protected species? And if we're doing that, what are we doing to minimize that? Can we come up with some solutions so that our fishermen can actually go fish and catch what they want to catch and leave the things that they don't want to catch back in the water undisturbed? And so that's what kind of the point of view I've been dealing with for the last several years. I actually was not a turtle biologist when I started my PhD. I'm actually a trained slug neurophysiologist. I'm actually well trained in slug neurosurgery. But somehow I found myself as a sea turtle biologist working with fishermen. So you get that. You train all your life for a certain job and you end up doing something completely different. You just never know. So it's one of those things. But before I dive in, I just want to point out my co-authors. You're not Swimmer. She's the actual researcher that brought me out here to Hawaii 13, 14 years ago to begin doing work on sea turtles and fisheries. I have a whole slew of other co-authors of all the different types of works that we do. I'll probably bring their names in from time to time. And before I really get into the guts of the talk, feel free to interrupt. We're a small enough group. If you have a particular question, just jump in, raise your hand, or just speak up. I'm more than happy to go with the flow. Obviously, if you look at my career path, it's all good. Okay. All right. Let's go ahead and get started. So the outline of my talk here. So there's really three different parts of my talk. I'll just begin very quickly about why is NOAA Fisheries even interested in doing international collaborations on sea turtle conservation throughout the Pacific. Okay, and there's a very specific set of reasons for that. Then I'm going to jump into the meat of the talk, which is about the different bycatch reduction research that we've been involved in. We've been involved in work in Japan, work in Mexico, work in Indonesia. A lot of that now has spread out globally, so that's been very interesting. We do a lot of work in gillnets, in particular coastal gillnets, and I'll talk a little bit about why we do work in coastal gillnets. And we've also started interesting work looking at acoustic deterrence. That's very new stuff that I wanted to let you guys know about, kind of hot off the presses. And then I'm going to end on kind of a more difficult note, but I think it's a very practical note and it encapsulates some of the issues that we deal with when we do international work. And one of the issues that we're facing and just started to reface is how do we deal with indigenous take, especially indigenous take of critically endangered species and take that sometimes can be fairly high. What do we do about that? Okay. So why is NOAA Fisheries even doing anything with sea turtle conservation? What are our mandates? So it's really driven by two sets of laws, the Endangered Species Act and the Magnuson-Stevens Fisheries Conservation and Management Act. Okay, so under the ESA or Endangered Species Act, we're mandated to protect, to conserve, and ultimately to recover species that are designated endangered or threatened. Under the Magnuson-Stevens Act, we're also mandated to deal with overfishing and reducing bycatch. right? What's bycatch? Bycatch is all the stuff that fishermen accidentally catch. They don't want to catch it, and oftentimes they throw it back overboard. And when they do that, oftentimes it's already dead or it's already compromised and will be dead very soon. In addition, we're mandated to rebuild overfished stocks, and ultimately, the ultimate game here is to have a safe and sustainable, and that's that keyword, right? Sustainable supply of fish. They reauthorized the act in 2006, and they put in an international provision. And that international provision addressed two key things here. Again, IUU fishing. So what's IUU fishing? That's your illegal, unreported, unregulated fishing. And that's what goes on in the majority of the world's fisheries, okay? Here in the US, our fisheries are fairly well managed. You go to any other country, and in particular any other developing country, and the situation is extraordinarily different. The other mandate was to deal with the bycatch of protected living marine resources. So again, it touches on the bycatch issue, and that's ultimately why we have these mandates, and those mandates drive why we do what we do, especially in the bycatch field, and especially when we deal with international fisheries. And so with that, over the last 12, 13, 14 years of being out here in Hawaii, working with NOAA, we get kicked all the way back to the beginning. Oh, maybe not. Okay. I've been involved in a variety of fisheries and dealing with bycatch issues. I've been involved in longline fisheries. So longline fisheries is a form of fishery where you just have a really long line. And off that really long line, you have up to 1,000 hooks in the water. And those hooks are typically trying to go for things that are pelagic, like swordfish. But if you go deeper, sometimes they'll go for tunas. And that's the main fisheries we have here in Hawaii. But you have this form of fisheries pretty much in every country throughout the Pacific. Coastalgill net fisheries. This is something you guys probably think of when you think of fishing, right? A small vessel, you go out, you throw a net, and you catch whatever you catch. But gillnet fisheries are probably one of the most destructive form of fisheries because they pretty much catch everything in the water that they touch. Oftentimes, we have this image of mom and pop going out, throw out a small net. But the reality is they're throwing out 3, 4, 5 kilometers of net, letting it sit all night long. And then when you think of places like the Philippines or Indonesia, you're talking gillnet fleets of 200 to 300,000 vessels in the water doing this every night. So you can think of the impact that it's having not only on the fish populations, but also all the protected species populations in the water. The other fisheries that I'll talk a little bit about are Paonet fisheries. I came from North Carolina, where I did most of my work. In North Carolina, in the Pamlico Sound, we have Paonets. It's a very passive form of fishing. Basically, it's a long fence you put in the water. Fish hit it, they come into these pounds, and they get collected, and they swim around. Fishermen come in the morning, they kind of scoop the fish out. In Japan, they've got basically the super Walmart version of this, right? Instead of a small pound, they've got pounds the size of their like a Walmart parking lot. So it's extraordinarily large. You're actually catching pelagic species. Some of these pounds have major issues because instead of being open to the surface, where air-breathing animals can get up and actually breathe, a lot of them are closed and are actually covered and underwater. So that means anything that gets into them and they need air, they're done. So that becomes a main problem for bycatch issues. So not only have we been involved in all these different places where we're doing work, we have been very much involved in our own fisheries here in the US. And so I think it's really important to realize that the management right now of the US Pacific longline fisheries here in Hawaii, so our Hawaii-based fisheries that generates I think the estimate is $300 million when you look at all the accessory components to it, right? So it's a major economic driver for our state. The management of that fisheries is really driven in part by sea turtle conservation, okay? And so what you have is, in essence, this particular fisheries, I'm getting disrupted because Todd is in the house now. Hi, Todd. You're coming in today. So what we have is earlier in the 1990s through the 2000s, well, the issue we had was this particular fisheries was interacting with a fairly large number of turtles, up into the hundreds of turtles, okay? And that created a huge set of issues for the Hawaii fisheries. And so in 2000, that fisheries was actually shut down. All right. So the fisheries was closed and was told to figure out a set of solutions before you can reopen. And during that time, NOAA was rushed in, was mandated to figure out a couple things, and came up with a set of possible solutions. One set of solutions was to take the traditional J hook and use a circle hook. So a bunch of our bycatch reduction engineers tested this and found that that actually really reduced the amount of turtles that could be caught when you use these larger circle hooks. And so in 2004, 2005, the fisheries was reopened with a set of very strong management measures, all of which, again, were directed towards reducing the interaction of that fisheries with sea turtles. One of the measures was, instead of using J hooks, you've got to use circle hooks. Instead of using squid bait, you've got to use fish bait. You're, at least in the shallow set fisheries, you're mandated to have a NOAA observer on the vessel. So you have to have a third-party observer actually writing down and seeing what's going on and seeing whether or not you interact with a turtle. And you can see, based on the graph here, almost immediately you have a reduction in turtle interactions. Our colleague, Yonat Swimmer, recently published a paper showing that the catch per unit effort, so when we look at our data, not only do we look at the catch, but we have to define that in the amount of effort it took to get that catch, right? When she looked at this, she showed that at least for the two main species of concern, the Pacific leatherbacks, we reduced the interaction rates by 84% when we went to this new regulation regime. And then we reduced the interactions with the North Pacific loggerheads by 95%. So what this indicated was, again, these management measures made a big impact on the bycatch of these animals. So currently here in Hawaii, we do have what's known as sea turtle caps, hard caps, for at least the shallow set longline fisheries, which targets primarily swordfish, okay? So in this particular fisheries, we are only allowed to catch or interact or take, so the word is take. Take really means not necessarily catching, but you're interacting with a turtle. You're taking 26 interactions of leatherbacks. If that happens throughout the fishing season, you have an immediate closure of the fisheries. With regards to the Pacific loggerheads, you could have up to 34 interactions before an immediate closure of the fisheries. Currently, we have 33 interactions. Right now, we have 33 interactions with the Pacific loggerheads. As a result, the fisheries has decided to shut itself down because they don't want to hit that 34, okay? So right now, our shallow set fisheries, which targets primarily swordfish, they're done. They're not going to fish. That's per fishing season, per year. Yeah.
Calendar year?
It is the calendar year? Calendar year. Okay. Yeah. In addition, when you look at green turtles or olive ridleys, there's another interaction rate as well. They don't necessarily trigger immediate closures, but they do initiate certain management actions. For example, biological consultations, etc. Okay? So keep those numbers in mind. Yeah, of course.
Why does the shape of the hook make such a difference?
Okay, so what you can see is if you look at this traditional hook, this is a 9/0 J hook. Do you see how narrow it is? Mm-hmm. That narrowness actually goes down the throat of the turtle. And so you have, when you catch a turtle or when the turtle interacts with that J hook, you have a much higher rate of hooking internally. With the much wider circle hook, that doesn't lend itself to go into the esophagus of the turtle. Oftentimes, when you do have an interaction or a take, the take is on the shoulder or elsewhere or externally as well. Or sometimes it slides in the corner of the mouth of the turtle. And so I think it's physically more difficult for the animal to actually ingest a hook than it is with a J hook as opposed to a circle hook. Okay, that's a great question. Yeah.
Put this slide up. I've been looking for the forthright. I can't understand what reinitiation biological consultations are.
That's a great question. I don't have the best answer for that. He probably has a much better answer. He probably has a much better answer. Well, we could talk about that later, but what it really gets down to is there's a series of management measures that requires NOAA to take a closer look at the fisheries and what they're doing. And then that can result in additional management of the fisheries, ultimately.
Typically say the 26 to the 34 turtles, there's an analysis done to that state level will impact the population. So if you go over the 6, causes a new analysis. Is the amount that we went over going to impact irreparably the population?
Okay. So, but what I want you guys to do is to keep in mind those numbers, like 26, 34, 6. These are kind of your trigger points for things, okay? All right. So that's what's going on in our fisheries, right? And ultimately, what's going on in our fisheries gets impacted by what's going on in the rest of the ocean, all right? And what I want to do is show you 3 cases, 3 examples of why that is, right? Sea turtles don't just hang around the waters here in Hawaii. They're very, very migratory. They go across the ocean basin in some cases. And a great example of that is the Pacific leatherback turtle, all right? It has a transoceanic life history. So in our case, we have a lot of the leatherbacks nesting primarily in Papua, Indonesia, so over here. When they're done nesting, several of them often take these transoceanic migrations that bring them all the way to the coast of California, okay? So they're swimming, in essence, back and forth across the Pacific throughout their life histories, all right? The other component that I think is very important is notice where the red is, okay? In this case, the black lines are your migratory behavior. So they're basically swimming. That's swimming behavior that they're on the move. The red areas are where they're initiating, in essence, feeding behavior. So they're spending time hanging out in those particular areas. And so while they're swimming across the ocean, they're perhaps not so much red, but on the coast, you see a little bit more red. And in particular, if we were to zoom in to some of these places like in Indonesia, but also in the Philippines, we see that they spend a lot of times in coastal waters foraging. What else is in coastal waters? Well, coastal waters is where in these countries you have a huge amount of fishing effort in the form of gillnet fisheries, in the form of bottom set long lines, in the form of purse seines, etc. So in those areas, we're pretty worried that those countries and those places, they're interacting with this particular animal, okay? And so that's what's generating some of our concern and our interest in wanting to deal with bycatch issues in those countries. Another great example of this is the North Pacific loggerhead sea turtle, okay? So North Pacific loggerhead sea turtles, they nest primarily on beaches in southeastern Japan. When they're done with that, they spend quite a bit of time in the oceanic phase, in the ocean, where they're, in essence, spending time here in the North Pacific. Then they end up, at least a subset of them, end up off the coast of Baja California in Mexico. Again, spending time as juveniles utilizing coastal waters for foraging grounds. And again, interacting or potentially interacting at high levels with coastal fisheries there, okay? And so again, what it comes down to is, in order to properly manage and deal with these declining species, we've got to work with other countries. We've got to work, in this case, with the Japanese. We've got to also work with the Mexicans. And so most recently, what we've had is a tri-national loggerhead recovery team dealing with how do we bring the population of this animal back up to recoverable levels. And so that team obviously has both Japanese representatives as well as Mexican and US representatives dealing with it. So it is very much a multinational, in this case, a tri-national team effort. A third example of this is the endangered green turtles. All right. So when we think of green turtles here, especially here in Oahu and here in the main islands of Hawaii, oftentimes we're thinking about the green turtles that go up to the French frigate shoal and nest. So, right, the Hawaiian green turtles. Another population of green turtles that we manage are the ones that nest out in Guam, Sinai, out in Yap, etc. Those turtles, when they're done nesting, those females make a beeline for countries like Taiwan, Philippines, northern part of Indonesia, where they in essence are spending time at their foraging grounds. And when you look at those foraging grounds, and again, try to think about what sorts of fisheries are overlaid in those foraging grounds, you can say, hey, as we have these species or these turtles here in Guam, Sinai, and Micronesia, as those populations decrease, what might be contributing to some of those decreases? It might not just be what's going on at the nesting beach. It can certainly be what's going on in the foraging grounds in these other countries, okay? And so again, when we think about the mandates that we have through Magnuson-Stevens Act, that says maybe we should be working with these countries and examining the bycatch issues out there, but more importantly, in solving some of those bycatch issues as well. Okay. So that leads me to the second part of my talk, which is the bycatch reduction work that we've been doing, right? We're going to talk a little bit about the Japanese Paonets that we've been working on. We're going to talk a little bit about developing net illumination in gillnet fisheries and how gillnet fisheries research has kind of expanded into many different countries now. And we'll talk a little bit about some of our work looking at acoustic deterrents. All right, as I indicated in Japan, they have a form of fishing called Paonets or teichami. These are huge structures, right? So in essence, it's again a long fence of netting. So when fish or other animals hit that net, they're going to typically turn and follow it inwards. And then they get corralled into a series of smaller and smaller pounds until they get into the caught end of the pound. And there's really two types of pounds. There's an open end type that gives you access to the sea surface. So things that, such as marine mammals and sea turtles that need to get to the surface to breathe, they can do so. But they also have a type that's roofed. And these nets are typically submerged, and that means animals that need access to the surface oftentimes drown. Our colleagues in Japan have been looking at these, okay? And so there are actually quite a few of these Paonets in Japan, all right? Not all Paonets are the same, like I said. There's mostly open type Paonets, and there's less of these closed Paonets. And the Paonets are not distributed evenly throughout Japan. So what this shows is the distribution of the Paonets based on the database that the Marine Ministry of Fisheries has in Japan. The red indicates about 50 Paonets per 100 kilometer of coastline, whereas the white is much less. Our colleagues in Japan have monitored 3 separate Paonets, one in Kagoshima, one in Kochi, one in Mie Prefecture. In Mie, that Paonet is a closed Paonet, right? So this is the one that doesn't allow animals access to the surface. The Kochi is a complex one, meaning it has a combination of open Paonets as well as closed Paonets. And the Kagoshima one is actually an open Paonet. So this is some of the data that comes out of these 3 separate Paonets that they've taken from 2007 to 2013. On average, each year in Kagoshima, you get 65 turtles caught in that Paonet. Because it's an open Paonet, most of those turtles survive. So their mortality rate is relatively low, about 2.5%. But when you get to, for example, Mie is a closed Paonet system. In that particular Paonet system, you can get up to 142 turtles on average being caught in that net with a 96% mortality rate. So that's a huge number of turtles dying in that Paonet, all right? On average, you have about 57 creta or 57 North Pacific loggerhead turtles, right? That's on average per year for that one Paonet, okay? In Kochi, where you have a complex Paonet, so this is the combination of open and closed, right? You get up to 110 turtles caught in that one Paonet, right? So this is per year on average. 82 of those are loggerhead turtles. Okay, what I'm trying to impress upon you is, again, some of these numbers are pretty high, right, in comparison to the numbers that we use to manage our fisheries. And I think that's important to remember, right? Again, when we think about turtles and when we think about how do we, as conservation biologists, deal with sea turtle populations, we've got to think beyond our immediate location and start thinking about how do we work with other countries and how do we foster our relationship with other countries to ensure that we have positive relationships to bring them up and also help create kind of a conservation ethic there as well. Okay, so this gives you an idea of just sea turtle catch rates per day. And because of those numbers, we started a collaboration with, oh, go ahead.
We've got bycatch here and other places. When you go to Asia, is it considered bycatch or a marketable product?
That's a wonderful question. That really gets at the heart of some of the issues here. I'm so glad you answered that, because we're going to talk about that at the very end of the talk when we talk about indigenous. Okay. But it really gets at this important question. Our values in the States are different from the values in other countries that we work in. So how do we deal with that, right? As countries, we've all signed on to a variety of treaties looking at conservation, right? But fundamentally, how do we approach that when perhaps our values are slightly different? And how do we go about and deal with those things? And give me a moment, and I cannot find my arrow. Oh, apparently I found it. Okay. All right. Hold on to that thought. All right. So as a first step, what we wanted to do was let's try to bring some of these Paonet fishermen together. Let's try and encourage the Japan Fisheries Agency and bring some of the managers in on this. Let's bring some of the industry stakeholders, for example, the net making companies, etc., into a conversation. And so at the Suma Aquarium, where some of our colleagues at the Sea Turtle Association of Japan are based, we initiated several different workshops to perhaps design solutions, in essence, to design escape devices for these Paonets, right? And the idea was, let's make sure we have this conversation with the Japanese fishermen alongside the Japanese fisheries managers. And that was really interesting because very quickly we found out that the fisheries officials don't always talk to the fishermen. They don't really have the best lines of communications, right? Much less, they don't really talk to sea turtle scientists all that often as well. And so it was a very interesting mix of things where I think we were finally developing interesting lines of communication through that, right? And part of this was we had something to do together. And that idea was, what can we come up with? What are some ideas we could put on a whiteboard? What are then, we can work with the net companies right here, right? So let's go ahead and build a variety of prototypes, and let's go ahead and use the resources of the aquarium, and let's go ahead and test those prototypes, right? So what we did was we built a model N, so the pound end of one of these traps, right? That allowed us the opportunity to basically put a turtle in it, wait to see whether or not it was ready to get out. Once it was ready to get out, we can test whether or not a prototype design was efficient or effective in letting the animal out. We can actually put fish in this to see whether or not the fish were getting out as well, because that's what the fishermen were really interested in the first place, right? But because we were doing this in this giant aquarium and we're all sitting there looking at this, we can really, the fishermen for the first time can really see what's going on underwater, right? They can see the turtles struggling to get out, right? The fisheries agencies can see, oh, you know, those turtles, are they going to drown or are they not going to drown? Obviously, we had safety divers ready in, you know, once the animals were at a certain level, we popped them out, etc. But it gave everyone that gut reaction, that gut feeling is like, is that turtle going to get out of this net before it panicked, kind of thing, okay? And so we were able to go through 25 prototype designs. We developed 4 Paonet escapes devices. Basically, we came up with some plausible solutions that the net companies were willing to take on, and that some of the Japanese fishermen were willing to give it a go, at least to test to see whether or not they can keep their primary fish catch intact. All right. And so that's still ongoing, right? I think we're in a couple different generations of this testing stage. There's, I think, at least 2 different designs out there right now. And we've got at least one set of fishermen setting up to test this this upcoming fall again. And so that's actually, I think, where we wanted to be. We wanted to go through this transition of getting some fishermen excited about it, coming up with tangible products, and then getting it into the field and really testing it out. And so it's taken a very long time for us to get to that point. I think the other really important component here is that entire arc of getting everyone involved, right? And I think that's really important when you think about how do we approach these international issues that are really, really difficult to think about and talk about. When we started this, there was a first Pacific Loggerhead workshop, I think it was 2005, 2006, when we're first talking about, hey, you know, you might have a problem in your Paonet fisheries, right? And just the incomplete, like, the Japanese fisheries officials did not want to talk about this. They did not want to deal with this. I mean, you can see they're just all sitting there going, hi. You know, they were not going to budge from that position, right? So how do you get them to move from that position?
Okay, so if you have the open Paonets, why cannot everyone move into that? Why do they continue to use?
They're actually going the opposite direction, right? So from my understanding, the open Paonet requires a lot more resources to use, okay? It requires several different vessels. So multiple vessels have to tend how they lift the net up, bring it up, and actually pull out and collect it. It's an expense thing. And then when you think about how the demographics of the Japanese fisheries is, there aren't that many young fishermen coming in. It's mostly, it's aging up, not aging down, right? And so they're trying to find more efficient ways of dealing with this. The closed pound net systems, from my understanding, are much more efficient with regards, you don't need to have so many vessels together, and you don't need that much manpower to deal with that, right? And so because of that efficiency, that's why there was a small trend going towards the closed pound net systems. At the same time, I don't think the Ministry of Fisheries was doing a good job of monitoring who's got open pound net systems, who's got closed pound net systems. This is just occurring organically, right? It's not coming from a top-down directive from the ministries. This is, they're catching on, like maybe we should be understanding how many closed pound net systems are there or how many open pound net systems are out there, okay? But that's a really good point. Yeah.
Maybe I missed this in the beginning, but what incentive do the fishermen have actually to reduce the number of
Sure. Of turtles?
Yeah, in their catch? Is that fish weight that they cannot then take to market? Do they get penalized for the number of turtles they catch, or?
That is, again, a great point. What are the incentives, right? What are your positive incentives? What are your negative incentives to deal with this? In this case, there weren't a huge amount of negative incentives in the sense that the government, they weren't reporting this up to the government per se, right? The government wasn't taking a very strong active role in the conservation of these issues up to this point in time, okay? They know that, however, this is probably a pending issue. Most fishermen are conservationally minded to begin with. Surprisingly, almost all the fishermen I work with, from Mexico to Indonesia to Japan, they don't want to kill things that they don't use. They don't. That's not part of their ethic. And so, but what do they do? What are their options, right? And so I think this is really important when you think about that, is how do you provide people with tools or with options to do something that's slightly different, right? And I think this is where things like developing bycatch engineering and tools, etc., really comes in, because now you have an alternative, right? But part of this was that arc that we saw with the fisheries officials, right? Where they started off very much not involved. But because we had these workshops, because there was engagement with them, because we were not necessarily saying this is evil, this is bad, bad. This is, let's work together to resolve this. Then they started to come to the workshops and go from being spectators to being collaborators. That's a huge step, right? And since then, from being collaborators now to the tri-national loggerhead recovery teams, they're central authors of this, right? They're central players behind this now, okay? But part of that arc really is that transformation. And that takes time, and that takes engagement. And that takes, I think, a really big part of, hey, look, we have our set of issues, you have your set of issues. Let's just work out those issues. Let's find creative solutions and give people tools. And what was really good about, I think, this particular set of workshops was it created a venue for that discussion, right? Up to that point, the fisheries agencies weren't really talking to the fishermen, who weren't really talking to the conservation biologists, right? Everyone is just doing their thing and not working collectively together. By having this at a giant aquarium, you had a lot of media attention. That media attention could have been very negative, right? It could have been, hey, you guys are catching turtles and you're killing X number of turtles. But you can turn that on its head in a workshop like this, where it's, hey, you guys are all working together to resolve, trying to find solutions and trying to resolve a particular problem. And then as a result, that becomes a very positive story. And I think that positive aspects help shift any potential for negative discourse. Yeah.
Or culturally, was there a market for turtles? Like eating the shells? Oh, yeah.
Well, so at least with the loggerhead turtles, they're traditionally, with hawksbill turtles, they have a traditional use for the hawksbill turtles to make jewelry, the Beko trade, right? For the loggerheads, I don't think loggerhead turtles are typically used in that trade. I don't think
Japan only, because Southeast Asia, I mean, if you roll it out south of there, it's a whole different story.
it is. We're gonna get to that.
I just want to make sure.
Yeah. We're talking Japan.
You're focused on Japan.
We're talking
Okay.
Japan. My understanding is most of the turtles that ended up dead were just put back into the water. They weren't utilized. I think someone did say like sometimes they eat the turtle meat, but I don't think it was commercially in that sense. I think it was maybe occasional, but loggerhead can't be the best meat to eat. Just,
Never tried it.
I have not tried it. I have not heard good things from people who have tried it. Green turtles is a different issue. Loggerheads, not so much. Okay. Anything else on this slide before I move on? Okay. All right. So that's kind of the story I had about kind of trying to create those relationships and try to foster communication and work in this particular setting. So now I'm going to talk a little bit about our work with Coastalgill Net fisheries. All right. So why work on Coastalgill Net fisheries? All right. Pretty much they're found everywhere in the world. It's one of the most common form of fishings. They're oftentimes small scale in nature. Okay. So small scale, I mean kind of artisanal in nature. Artisanal typically means non-mechanized. You basically are going out with small, horsepower motors. You're laying nets by hand. You're not necessarily using a giant reel to reel everything in. It takes several hours to actually pull in your catch. Though they still put out up to several kilometers of net. I mean, it's just hard work. Okay. Oftentimes these fisheries are poorly regulated, right? They're typically in places where that top-down regulation just doesn't exist. Which also means they're poorly monitored. So you don't oftentimes know what's being caught, how much is being caught, when is the fisheries actually occurring, etc. These nets typically have low selectivity, meaning they catch pretty much everything in the water, right? So you have high interaction rates with turtles. You can have high interaction rates with seabirds, sharks, marine mammals, you name it. These types of nets seem to catch a lot of these things. There's very few bycatch reduction solutions associated. Unlike a circle hook, which had a physical way of preventing a turtle from swallowing it, right? How do you prevent something from getting tangled up in something designed specifically to tangle something up, right? It's just one of those things. It's really hard to figure out. And because these animals are typically highly migratory. It's a multinational issue. But how do we deal with this, right? And so again, it gets to that point. Is there a way we can provide some tools, right? Some solutions, at least then some alternatives. And so that's really where I got pulled into this about a decade ago. And the approach that we started off with was we wanted to understand the basic physiology, the basic sensory physiology of turtles, and ultimately their behaviors, and use that to help drive development for bycatch reduction technologies. And so obviously animals, marine animals, they can hear things, they can see things, they can smell things. Some animals can actually sense the Earth's magnetic field. All of this kind of combines together, creates a behavior so that when it approaches fishing gear, that behavior gets changed in some way, right? Sometimes it gets attracted to it, sometimes it gets repelled from it, etc. Vision is obviously a dominant sensory domain for most marine vertebrates. So that's actually why we settled on vision. And one thing that we can really do is change the visual cues. One way of changing the visual cues is just put a light stick on a net. Oftentimes, many of these net fisheries occur at night. So the fishermen go out, lay their nets in the evening, let it soak overnight. Early in the morning, they go, haul the net before it gets too hot, and then go sell their catch, right? So it's a night set. At night, if you put light sticks on these nets, you change the visual ecology of that net, right? Light sticks are fairly ubiquitous in the fishing industry, right? You've got the chemical ones, you just crack them, shake them, you've got a chemical light sticks. You've got battery powered LED light sticks. All of this is already out. They're out on the shelf and fishermen can go buy them. And that's something that we did, and we just figured we should go ahead and test that. We did the testing primarily in Mexico because it gave us, we were able to develop a really interesting experimental system in Baja California, where in one part of Baja California, we were able to catch lots of sea turtles. And in another part, we were able to engage in fishing, in gillnet fisheries, working with the local fishing villages. All right. So that kind of gave us a sense of what could we do what would happen when we would put lights on these nets. All right. And so in the places where we knew we could catch lots of turtles, we put lights on the nets, one every 10 meters, right? On a control net, we just basically put a light that didn't turn on one every 10 meters, right? And we just one net in the water, saw what happened, right? And what we would see is we can get a decline in turtle interactions. So you would have more turtles in the net that had lights that were not turned on. So just your normal net, right? When you had the lights turned on, you actually had a reduction in turtles, right? When we did this on fishing nets, because we want to see how does this affect the catch, right? At the end of the day, we can't reduce the fisherman's catch. If we reduce the fisherman's catch, they're just not going to do any of this, right? When we looked at this, we saw that control nets and the nets with the LED lights had the same catch rate. So basically, the fishermen were catching the same stuff. That's great news. We were able to follow that to the market. We also showed that the catch value was more or less the same. Again, great news. So a plausible solution, right? A plausible solution, but we were only doing this in a testing model system, right? We did this with a variety of lights, chemical light sticks, LED lights, UV LED lights, long wavelength LED lights. In every case that we put a light on the gillnet, we actually reduced sea turtle interaction rates. And at the same time, we did not change the target catch rate or the catch values. So that was great. Those studies formed the basic foundation of what we wanted to do next, which was we wanted to take this and try to convince some fishermen in a real fisheries that have a real turtle issues to let us try this, right? So this basically gave us that foundational information to go to some of these fisheries. We found that fisheries in Peru. Our colleagues down in Peru, Joanna Alfaro-Chigueto and Jeff Mangle, they run an NGO called Pro Delphinus. Pro Delphinus has been working on bycatch issues in coastal fisheries in Peru for over 2 decades now. They showed that in northern Peru, the small-scale gillnet fishery interacts with over 6,000 turtles per year. So that had a huge turtle interaction rate, right? And so we wanted then to find a way to work with them, okay? And so that was great. They're excited by the data that we had in Mexico. They wanted to give it a go. So we conducted their paired gillnet trials, right? Control net, experimental net, threw it in the water, real fisheries, real dirty fisheries, just, everything you can think of, like it's not easy working in these places, right? Managed to complete a series of 114 paired trials. And what we found was the target catch, primarily rays and guitar fish, stayed the same. Caught the same target. Fishermen were very happy. We saw a 65% reduction in sea turtles. That was statistically significant. All right. So that was our first hit there. Boom. We got it. We showed that in this arc, if you change the sensory ecology very simply by using LED lights to change what the net might look like at night, you can really get a major reduction in turtle interaction rates. So when you think about what that might mean for other fisheries around the world, that becomes very exciting, right? So this worked in Peru, but what about other places, right? We talked about how gillnet fisheries were very ubiquitous. Go ahead.
I'm sorry, I missed the name of the fishery.
We were working in,
Nonprofit.
the nonprofit was Pro Delphinus.
Pro Delphine.
Yeah, Pro, then Delphinus.
Types used with a steady or strobes?
They're steady. But very good question, because we've talked a lot about strobes.
Well,
lately.
strobes, frightening away.
We don't know. I think it's one of those things that I've learned the hard lesson is we can make all sorts of assumptions, but until you test it, you just sometimes don't know. So, okay, but if you use strobes, you actually reduce the energy consumption, and there's all sorts of engineering things that go with that we've been looking at lately. Okay. That gave us a springboard to try that in other places. So we ended up in Indonesia. WWF was very excited about the work that we did. We managed to actually win were runner-up for their Smart Gear Award. That opened us then a bunch of doors to try this in other places. And so, for example, we've been out in Indonesia for the last several years, in Borneo, in West Kalimantan, working in the fisheries. Obviously, we picked the one fisheries that is so far to get to, the hardest place at the end of the road in Borneo. But yet, that's where we ended up. Part of the reason why we're out there is because this particular fisheries has fairly high interaction rates with green turtles, olive ridley turtles, hawksbills, and on occasion, leatherback turtles, right? And it operates off a turtle nesting beach. But what's really neat about this fisheries was the fishermen were really motivated to not catch turtles, because when you catch a turtle in a gill net, it ruins your day, because you spend the next 3 hours untangling that net, and odds are you're just going to end up with a giant hole in your net. And then you've got to spend the rest of the day repairing that hole. And that kind of sucks. And they were catching lots and lots of turtles to the point where they're just spending all day fixing nets. And so they were highly motivated with regards to wanting to reduce their interactions with turtles. So we went out to Borneo, and first thing we did was we had to establish an observer program out there. So we had to train up people to go out on these fishing boats to be those observers that we have here in Hawaii, right? To write down when the nets are in the water, what do the fishermen catch, what are the turtles that they catch, do the measurements, collect the data, etc., right? We had to establish a variety of management protocols, because the first year, the data sheets were just coming in all willy-nilly and like, oh, no. We're just going to have to make this a little bit more organized. But we were able to get over 200 observed gillnet trials out the door, all right? And that's been very interesting. And we're in the process of finalizing that analysis and getting this particular study out the door. What we're seeing is at least a 50% decrease in turtle interaction rates here when we use the nets that have the LED lights. In addition, we're seeing actually an increase in their target catch, which are pomfret species. Fishermen saw this right away. They knew that. And within the first 12 trials, they were like, oh, we like these lights. We're catching some more fish. We like these lights. We see 0.25%. We see 25% more in value for them. Right away, they know, because they're keeping track of that, right? So that's helped us with regards to getting other fishermen involved in this area.
Why does it deter the turtles but not,
I don't know.
nobody knows?
Nobody knows. I think what we're going to find is the lights will deter some animals and attract other animals. And I think when we actually really start to scratch the surface at this, green light might do some fish, increase it. It might decrease other fish, whereas blue light might reverse that. And I think it becomes a very interesting prospect about, can we tune a net using the visual ecology in a certain way? So depending on your management need, you might want to catch more of something some of the time, but less of something other parts of the time, depending on the season, etc. And so that becomes a very interesting question down the road. I don't think we're anywhere near that, but that's certainly entered our mind. So that was a great question.
What about the cost of the lights?
Oh, I've got a perfect slide for you at the end. Okay, let's go. Okay. The cost is an issue, and we're dealing with that issue. And so, like, I'll definitely talk
So
about
I'm
this.
thinking, okay, if they get an increase in their
Right.
target, then it might offset it. But
It
otherwise,
might offset, right?
If not,
But if not, it becomes a problem. And then ultimately, how do we think about, why do we always feel that we have to pass the cost of these things onto the people that can least afford this, right? These fishermen don't make a lot of money. We value turtles. Why are we passing the cost onto them? So think about that.
were the lights built in with the nets, or were they just gone down and put?
They're just going down and putting on.
Like, put
No, every we're attaching it every 10 meters,
but not
Yeah.
attached to the net permanently.
Yeah, yeah. which is also a problem. Yeah. Okay, more questions.
Your last statement was really very nice, about not passing costs down. How universal is that in protecting the environment?
I don't
Other
think
than your business?
I don't think we think about that enough. I honestly, when we start talking about cost, I think everyone kind of freezes because no one wants to pay that cost. Because there is a cost. There will always be a cost to change, and there will always be a cost to protect the things that we want. And so how do we go about actually having an honest discussion about that? And I think it brings up maybe some unpleasant issues there. So.
What's the biological or maybe psychological reason turtles are evading the net?
So this is just my conjecture, my hypothesis. I think the turtles actually, because the lights are illuminating the net, I think the turtles are actually seeing the net. I think the turtles, because I've been in enough situations where we're pulling the nets, we see the turtle, we back off, and it's just swimming along the net, and then finally decides it veers off and it's out of there. I think it just sees the net and realizes that it's a barrier. I don't know if it has a concept of what a net is, but it sees a barrier.
Reptiles are not that smart.
I kind of agree with you there, but yeah, but I think they're highly in that sense. I do think that they literally see the net and at that point see a barrier and make a decision. Okay. Oh gosh. Okay. 5 minutes. All right. So where are we now with this, right? Over the last year and a half, we've had a lot of interest in this work, and this work has started to really expand. We're initiating gillnet trials in a bunch of different places. We started having these discussions with our colleagues in the Philippines. Our hope is to do rapid assessments in the Philippines, to understand where there are some hotspots that might have sea turtle issues, and to engage with the Filipino Bureau of Fisheries there, and to perhaps do some of this work. So those are ongoing discussions. We have an ongoing study already in the water in North Carolina, in Pamlico Sound, back all the way out back east. There's a summer flounder fisheries that has a major problem with catching turtles. So they're already initiating those trials. I just actually got back from the Adriatic where the EU invited me out to help them get some trials off the ground, off the coast of Slovenia and Croatia. They have a major issue with loggerhead turtle bycatch there. They're going to probably be one of the top loggerhead bycatch countries or fisheries when it's all said and done. And so they're really wanting to test this, and I really want to see whether or not this works also on loggerheads. We have colleagues in Ghana that initiated a set of trials about 2 years ago. They're kind of halfway through those trials. And so it's been really interesting to see colleagues in Africa take this on and give this a go. And then most recently, I was on the phone with colleagues out in Pakistan. They did a trial study over the last 2.5 months out of Karachi. They had a phenomenal set of trial studies. In those studies, they saw a very large increase in their target species. So they're very, the fishermen are very happy about that. And this particular region has a major issue with olive ridley turtles, okay? The other aspect about this is we're guessing that most likely other vertebrate marine species who rely on visual cues will also respond to these light cues. Just a week ago, we published a paper looking at seabirds out of work done in Peru. So we're showing that this actually has an impact on seabird bycatch. And so we're very excited about that. We have
Positive, negative.
a negative, so an 85% reduction. So that's really good. We're in the process of reviewing a paper looking at shark bycatch reduction, so about a 46% reduction in shark bycatch. And we've got an ongoing study in Peru, which we're just starting to wrap up. Knock on wood, we've done the analysis. It looks really good. I'm not going to talk about it too much other than we're super excited. And if we get that, that will really cap us off, in which case. So my guess is net illumination not only will be effective in reducing bycatch for sea turtles, but will also be effective in reducing multiple taxa of species.